So in this video, I decided, you know what, we still can do this. Actually, we still have another style of implementing the same program of concatenating two IO strings, and um, and so in the first style, we started with this imperative style using the do block, and then in the second style, I was using the idea that the IO is an instance of the functors type class and is an instance of the applicative functor. And in the third style, I then went back and revisited the idea that because IO is basically a monad, I started using the lift M2 method, where I was able to lift this concatenation method from the purity world where it would work on strings, and then I was able to lift it so that it could work on this monadic expression where I had it as an IO string, and giving you back the concatenated IO string. But because one of the styles that we looked at was that because IO is an instance of the functor type class, is an instance of the functor type class, and is also an instance of the applicative functor type class. One other approach could be, you could also implement this specific problem. I just got this from Google, and from Google, what I know is that the signature for the lift A2 is very analogous, very similar to the lift M2, but in this case, I'm again just exploiting the idea that an IO is an instances of these two type classes here. So what does lift A2 do? Well, lift A2 basically, there's a class constraint. And the class constraint is that that the f that I'm dealing with here, must be an applicative functor, and because it must be an applicative functor, as long as I can provide in a method that takes in these two arguments here. That's my first argument, and this is the second argument, and that's the reason why this 2 comes from, okay, because I have these two arguments in my method here. And I can take this method and I can lift it so that I have now an applicative functor value. So I can now pass in two applicative functor values, and I get back a third applicative functor value. Okay, so again, this is the same idea as the lift M2, where in the previous case I was exploiting the idea that IO is a monad, and I could immediately start using the lift M2. But here I'm also just using the knowledge that I know that is an applicative functor as well, and because it's an applicative functor, I can actually even make use of this specific method lift A2 to complete the concatenation of two IO strings. So the way I would do that is I would say lift A2, and I need to pass in this method. That takes in these two arguments and gives you back some kind of an output, and that method over here is my concatenation method plus plus. Okay, and then I need to pass in two of these functor values, and these two functor values are going to be my IO strings that's coming from getLine and getLine. Okay, so again, getLine, the type of getLine over here is basically an IO string. This is an IO string. This is an IO string. Okay, and I know that F in this case is acting as my IO. Okay, if F is acting as my IO, then the constraint is that this F, which is your IO, must be an applicative functor. I also know that I know that IO is an applicative instance of an applicative functor, and by having this implementation to my lift A2 method, I can now perform concatenation of two IO strings. So let's just try that out. On my terminal here. So in fact, I did this previously, but let's just do this once more. So I have my concatenate binding here, the local binding for concatenate, and I'm passing a lift A2. I'm calling my method lift A2. That's going to lift the concatenation method plus plus, so that it now works on two IO strings, getLine and getLine. Okay, so let's just try that out. And if I say concatenate, and I pass in a bus, and let's say I pass in academy, I'm going to concatenate my two IO strings here, bus and academy, together to get back my IO string, bus academy. And again, the type for concatenate here is basically an IO IO string here. Okay, so again, I hope that this is something. Again, we're playing with a really, really trivial example, but it does bring these profound ideas by playing with different styles of of these ideas to work on one problem. So I hope this was useful of exploring these four different approaches, and I hope you enjoy your time learning Haskell.